Well, yeah. What you're doing is you take the mass and multiply it by the decimal form of the percentage, and then you add all those together. Okay.
Thanks, Jimmy.
So look, you take the mass of the first one, multiply it by the decimal of the percentage. So you're moving the decimal 2 places to the left. That's all you're doing. So it's going to be 0.9223. And then you're going to add that to the next isotope. So the next isotope has a mass of 28.97649. You're going to multiply that by this decimal form of this percentage. So you're moving your decimal 2 places to the left, which would give you 0.0468. Now, here's a mistake that people always make. A lot of times people will like only move the decimal 1 place because it's like, well, 0.0468, that's really small. Well, yeah, it is, but you still have to do it. So move it 2 places. I don't care how small the percentage is, still move it 2 places to the left. And your third isotope, you have 29.97377. And your decimal, you got 0.0309. All right, is everybody with me how I got those numbers?
Why is it 0.0468? Would it just be...
Right here?
Okay, never mind, it's a percent, I get it.
Yeah, you just turn it back into a decimal.
So whenever it's a percent, you just move it over.
You're basically dividing it by 100, but if you move your decimal 2 places to the left, it's the same thing. All right, now go ahead and plug these into the calculator. So the first one, you got 27.97693 times 0.9223. That's going to give me 25.803122 for the first one. Second one, 28.97649 times 0.046. Oh, crap. Got to do that again. 28.97649 times 0.0468. And that's going to give us 1.3560997. And then finally, 29.97377 times 0.0309. That will give me 0.92618994. Then you just go ahead and add those 3 together. So plus 25.803122.
Wouldn't it be quicker if you just did the first problem? Without breaking it down.
Did what?
Wouldn't it be quicker if you just typed the first problem all in the calculator instead of breaking it down?
You mean type this whole thing in the calculator?
Yeah.
Yeah, you can, but you have to make sure that you put all your parentheses and all that in the right place. And I want you to see the step-by-step process. All right, so this is your final answer, and it's going to be AMU. Now, again, notice, if your average is not in between the highest number and the lowest number for the mass, it's wrong. Like, I don't care what you did, but it's definitely wrong. You need to make sure that it's in between those 2 numbers. Yeah, Jill?
So we don't have to actually write out all 3 of those numbers.
Hold on,
All we have
Jimmy.
to do is the final answer.
Jill?
Do you take the 2 numbers in the parentheses, do you multiply them or add them?
So I'm multiplying these, multiplying these, multiplying these. And then these are the answers that I got. And then I added those 3 together. All right. Jimmy, what'd you say?
So, like, you know how you wrote down, like, 3?
Yes.
Right, like, no, we don't have to write down all 3. We can just type it in on the calculator, right? Like, you're not looking for us to...
You don't have to, but I am telling you this, okay? You need to make sure that when you do this, you put these things in parentheses if you're going to type it in all at the same time. Because if you don't, calculators don't always follow
They do pumpkins.
real good order of operations.
I just did the same, that whole equation and I got the same answer.
Okay,
Yeah, same.
that's great. But what I'm saying is, like, you need to make sure that you put it in correctly, because calculators, if you don't follow order of operations, you could end up with the wrong answer. All right, so this is our final answer. And again, another thing that I want you to notice, this is by far our most abundant isotope. So our average should be really close to this, which it is. It's just a little bit above it, which the other two isotopes are higher, so you would probably expect that. But your average should be closest to that. All right, now go to the second one here. On this one, we just have two isotopes. So we have rubidium 85 and rubidium 87. So 85, its mass is 84.9118. And it is 72.15% abundant. So that's going to end up being 0.7215.
I think I understand this part.
You don't or you do?
No, I feel like I do.
That's good. And then the next one is 86.9092. And that one is 0.275 or 2785% abundant. And so if we go ahead and work these out, all right, you got 84.9118 times 0.7215, and break that down. It's going to be 61.263863. And then the second part, you got 86.902 times 0.2785. Oh no, I messed it up again. All right, 86.909. Need to get another calculator. 86.9092 times 0.2785. Okay, that's going to give us 24.204212. We add these together. 61.263863 plus 24.204212. All right, that's going to give us 85.468075 AMUs. And if we round this off to 4 decimal places, because that's what your other masses have, we get 85.4681 AMUs. Okay? That's going to be your final answer. And again, it should be in between your highest mass and your lowest mass, which it is. Yes, Grace.
When I do it on my calculator, I'm getting like 2 extra digits on the end. So,
Probably because you're forgetting
it's because our calculator just
So
has
what are
like more.
entries?
No, it's how many.
Yeah.
This one's about 2.
It may give you a couple.
Yeah, I get like 2 more digits than you.
For one thing, this calculator is limited on how many digits it's going to get.
That's what
Okay, it's only going to give you as many as the screen will hold. So it's not saying, like, sometimes your calculator will round it off. But again, calculators don't care about significant figures, so it's not going to take that into consideration.
Oh, so we do need to follow the sig fig.
Well, this is what I'm saying for this. However many sig figs that your original masses have, stick with that. Because that's just an easy way of doing this.
I thought you said digits.
What?
Well, it is. It's still going to be digits.
What if it's not digits?
But you're going to go with the number of digits that you have in your mass, which here is 6. Okay? That's what you're going to worry about in this case. All right. How do we feel about this? Pretty good? How many of you would like to see another example? All right, I want you to take a few minutes and work out number 3 on your own. Okay?
benefits or